Welcome to biology. This presentation is about microscopes. And you probably have used microscopes in other science classes before. This is just a review of the different parts that are important for the microscope, a little bit about how you figure out the overall magnification. As far as operating the microscope, it'll be really important that you stop in and do the lab if you're watching this presentation because you missed class. We're going to be using microscopes quite a bit in the beginning part of this semester, and we'll also be using them a lot next semester too. We'll be making some observations about different types of cells and what's in there, and different types of examples of cell parts, and then in the end you'll be assessed about how well you're able to use the microscope. So please do pay attention to the parts as we go through them, but also make sure that you're getting the exposure to being able to work with the microscopes too. The microscopes you have in your notes is up to these different parts that are important here. And the first one to label within your microscope diagram would be the eyepiece. Now these microscopes that we have in our classroom have two different lenses. And one of those lenses is up top in the eyepiece. This will be the part that you look through, of course. Second, we have an arm. That's one of the parts that we're going to hold the microscope by. And third, we have a series of objectives. This particular microscope and the ones that we have in the classroom have three different objectives. This is where the other lens is located. So three different objectives here. There's a low power that tends to be the shortest one, and a medium power objective, and a high power objective tends to be the longest. Within each of these objectives is a different lens, and when you rotate this wheel, you'll put that lens in position with the eyepiece lens, and they will work together to help really magnify the object that's on that slide. Number 4, where we place this slide, would be the stage. And the stage, in this case, shows stage clips. Personally, I think they're kind of a pain to work with. Whatever works for you. You want to use the stage clips, fine. I just find that when I finally find what I'm looking for, trying to put the stage clips in place means that I end up losing the image. It gets nudged around a little bit. So your choice, whatever you want to do with the stage clips. Number 5 and 6, we have two focus knobs. We have a large one that we call the coarse focus knob, and a very tiny one called the fine focus. The coarse focus is used to raise and lower this stage very quickly. This is typically used only under low power. We always start with the stage all the way down as far as it can possibly go, because then we know the only place for that stage to go is up. And it might take a while to get that stage up high enough for that image to come into focus, but we're going to be moving that using the coarse focus knob first. Really raise the stage to a point where we can start to maybe get a better image. Once we get that into focus under low power, if we want to zoom in under medium power or eventually under high power, then what we would do at that point is use the fine focus. Two reasons for that. One, the coarse focus knob moves things very quickly, and the fine focus moves the stage very slowly. Small little adjustments. Under medium power and especially high power, if we raise that stage very quickly, we run the risk of cracking the slide as it gets wedged underneath the high power objective. The other is we've already focused the image under low power with the coarse focus knob. We're in the right area. We just need to give it a small little adjustment. And so under medium power and high power is when we use the fine focus knob. If we end up losing the image under medium or high power, then we just have to start all the way back at the beginning. Stage all the way down, use the coarse focus knob under low power, and then keep going from there. Sometimes it's helpful to make adjustments with this part here, and it's called the diaphragm. These microscopes are called light microscopes because light is coming from this source here, passing through the stage in your object, and eventually passing through to your eyes so that you can see it. But if you're working with a sample that is very, very thin, blasting that sample with a large amount of light is going to make the object not stand out. You're going to lose some of the detail. And so we would want to adjust the diaphragm to actually reduce the amount of light that we are passing through the slide. On the other hand, if we're working with an object that is really thick, you're going to need to use more light, and so we'd open that diaphragm up. Encourage you when you do the lab to play around with that adjustment there and see the difference that it makes. And then ultimately down below here we have a base. When we hold the microscope, we're going to pick that up by the arm and the base. 2 hands to make sure that it's secure so that we don't end up dropping this important piece of equipment. So we always carry the microscope by the arm and the base. We also always begin by finding the object using the coarse focus knob and the stage down under low power. Hide that. Use the coarse focus knob only with, again, low power. So the big wheel, big adjustments, only low power. Otherwise, medium and high power, we'll use the fine focus knob. To figure out the overall magnification, because there's a lens in the eyepiece and a lens in the objective, we take those 2 numbers and we're going to multiply them together so that the overall magnification is equal to the eyepiece multiplied by the objective. The eyepiece is typically 10x, which means that the object is being magnified 10 times by the lens that's in the eyepiece. The lens that's in the objective, well, it depends on whether it's low, medium, or high power, but the low power one is typically 4x. To figure out the overall magnification, we take those 2 numbers, multiply them together so that in this case, it would be 40x. The object is being magnified 40 times the size that it normally is. And that's it. At this point, again, if you need help with any of this, or let me know. Alternatively, of course, you can re-watch this video. But again, encourage you to come on in and do the lab so that you get that practice that you're going to need to be able to do well in the labs that we do and also on the microscope test at the end of the cell unit.